Okay, so this is one of the most tricky questions that you could possibly get, because you are going to have to deal with simultaneous equations, but you've just got to think of it really logically. One thing that I always have to do is just draw a diagram, because at the moment all these words sort of just confuse me. Just to start off with, I'm making everything upwards positive, like I always do. Again, if you want to make downwards positive instead, that's absolutely fine. You should still get the same answer. So we're told that there is a ball A that falls vertically from rest at the top of a tower. So this is my tower, which is 63 meters high. So we've got A falling downwards. Okay. So in a moment I'll do the Suvat part. Then we've got another ball that is being projected vertically upwards from the bottom of the tower. So this is my ground level. Okay. So B is being thrown up into the sky. We know that the speed is 21. So because my up is positive, that means that's still going to be positive 21. Okay, so these two are going in the same direction, or same direction towards each other, if that makes sense, so that they then collide. Okay, and we need to find the distance. So I'm going to start off with the A one. So using Suvat. So it started from rest, because it says falls from rest. That means that the speed must be 0. Okay. We don't know the speed when it hits the other ball, so we've got to leave that one. A is the acceleration, so that's the gravity pulling it down. So that's going to be negative 9.8. The distance, so it started here. That is when the distance is essentially 0. So that means the distance when it's going down is going to be negative, because it's lower than where they started. And I'm just going to call that SA. Okay, so we don't know what that distance is. And it's not going to be the same as the distance from B either, because we don't know what speeds they're obviously travelling at. And I'm going to just write T here. Okay, so I'm going to be using the S equals UT plus a half AT squared, and I'm just going to form an equation using the SA's and the T. So S is minus SA, U, so that'll be 0 times T, plus a half times minus 9.8 times T squared, which simplifies to minus SA equals minus 4.9 T squared. But obviously, because they're both negative, that means that I can write them as both being positive. Okay, so that's my one equation there. Then we're going back to B. So again, Suvat. Now this time we know that the speed that it started at was 21, so it's going to be 21 there. We don't know the velocity of when it hits the other ball. We do know that the gravity is the acceleration, but because that's the acceleration is pulling it down, it means it's going to be negative. And the distance up, we're just going to call SB. Now this is positive because it's going in the positive direction and it's increasing from the ground level. And again, we don't know what T is. So we're going to be using the same equation as the A1. So again, we just sub it all in. So SB equals, it'll be 21T plus a half times minus 9.8 times T squared. So SB is 21T minus 4.9 T squared. Okay. One thing we do know is that wherever these two balls meet, these two distances, the SA and the SB, they must add up to 63, because that's the total height that you have. Okay, because we're told that the height of the tower is 63. So if I add these parts together, so the right hand sides of both of the equations, that should then be equal to 63. So 4.9T squared plus 21T minus 4.9 t squared must be equal to 63. So all I've done is change that to this part and change this to this part. Okay, now these are going to cancel each other out, so we're left with just 21t equals 63 meters. So then t must be equal to 12 by 21, must be equal to 3 seconds. Okay, so that's telling me what the time is. So then we can put it into one of the, we're going from the ground, so it means that we've got to focus on B. I'm running out of space. Move it down a bit. There we go. So we're going to go from B, okay, because this one is from the ground. From ground. And in the question it said, find the distance of when the balls collide at the bottom of the tower. So that means at ground level. Okay. So we know that SB was equal to 21t minus 4.9t squared. So all I've done is use that formula here. We now know that t is equal to 3, so we can just sub in 3 into there. So 21 times 3 minus 4.9 times 3 squared. (21 times 3 minus 4.9 times 3 squared), and we get 18.9 meters.